So for the comparison or relational operator, we can compare structure variable member-wise. Okay? Take note that there's no aggregate relational operators allowed. Okay? To compare the values of a student in the new student, you cannot perform aggregate operation. So for example here, if I'm going to test whether the first name of the new student is equals to the first name of the student object, you cannot perform if new student is equals to student. That is not allowed. We can only perform aggregate operation if we want to assign values within a single structure. But if we're going to test whether the values are the same or we're going to make use of the comparison operator, we need to identify and we need to include also the member within the struct. So what's the correct format or the legal one? If new student dot first name is equals to student dot first name. So that's actually the correct format on how are we going to perform comparison operator. So take note also in the input and output, no aggregate input and output operation and a struct variable. So that means we need to again specify the member if we're going to input or ask the user to input the values or output the values of the members inside the structure. So data in a struct variable must be read one member at a time, and the content of structure variable must be written one member at a time. So for example, I want to display the value of first name. So I need to use cout new student dot first name. You cannot actually use cout new student only. So if you want to display the entire values within the structure type, student type, specifically into an object of new student, you need to identify the member so that you can actually display the value. So this example, first name, that means you are displaying already the value, Lauren, in our example. New student, that last name, meaning the last name of the student, which is Fuentes. Then the course grade, test score, programming score, and the GPA. So you need to specify the members so that you can actually display the entire value in a structure. Now, we can also perform struct variables and functions. As mentioned a while ago, we can apply structure in function. So if we have, for example, a pass by reference and pass by value for a simple variable, pass by reference in an array variable within the parentheses or an argument, we can also perform a struct within the parentheses of a function as function arguments. Okay, so in this case, for example, student type here, and then student. Okay, so void meaning no return value. You just want to display the value of the student in a function. Then you're going to make use of the structure name, and then you need to create a parameter, which is the same thing as the object that you're going to declare in a structure type value of student type. Okay, then a function can return a value of type struct. So that means even that is more than one records or more than one fields within a struct, actually we can actually use here also a structure name or a structure type and return the value as a structure value. Okay, that is only for a single structure. So take note of this. This is the last part of the part one of the discussion for struct. We can actually differentiate array to structure. So take note that in an array declaration, if we're going to perform arithmetic operation, we cannot perform aggregate operation as well as in a structure. You need to identify and access the members using its member name. Okay, same thing as array, you need to identify the index value so that you can perform arithmetic operation. Okay, but in the assignment operation, we can actually perform aggregate operation like what we did in student equals new student or vice versa. But for array, again, we cannot perform aggregate operation. We need to specify the index, okay, for copying the value of an array into another variable of array. For the input and output, we cannot perform aggregate operation except, remember, strings. Okay, strings can perform aggregate operation, But for array and for struct, we cannot perform aggregate operation. Again, you need to identify and specify what should be the input value for identifying the members. Same thing as with the comparison operator, you can perform aggregate operation by both arrays and struct. In function, when we are dealing with parameter passing, which is actually the content of the parenthesis in a function declaration, array is just only by reference only, but for structure, we can perform by value, since we can return the structure value, or by reference if we're going to declare an array structure already. And then lastly, function returning a value for an array, since that is passed by reference, there's no need for us to return any value or to use return statement. But for structure, we may use it because we can actually, again, pass the value of the structure. So that means that's yes. So for example, let's use the code earlier, the snippet codes, which is actually student and new student. Then we want, for example, to copy the value of the student to new student using the single structure. So this is actually the format on how are you going to perform structures within your code. So first is, of course, the header file, and then your global declaration, if any, and then your structure definition, and then your function declaration, if any, and then followed by the main program and the rest of the functions below, if any. So let's have a declaration for structure first, and then later on, let's expand the program by using the function declaration and definition. Okay. Okay, so for the structure, again, let's use the definition earlier. So we have to type struct, and then we have to use the curly braces. So automatically, when you put the curly braces or the open curly braces, it will automatically type also the closed curly braces and also the semicolon. So within the structure type, okay, so we need to identify what's the name of the structure. Here we use student type. And then within the student type structure, we define or we declare data types and members. What are the data types and members? Again, let's perform string, and then let's make it shorter variable name, F name. Then I have also string, L name for the last name. And then we have car for the C grade na lang. And then we have also, for example, double for the T-score or test score. And then we have another double for the P-score or programming score. And then lastly and finally, we have the GPA. Let's make it also double. And then we have the GPA. Okay, so that's how are we going to define the structure. We define it globally, not within the function. You can actually define this in the main program, but if, for example, we're going to have a function later on, okay, below the main program, better to use the structure definition globally instead of doing it within the main program. Okay, so now for the declaration here, how are we going to make use of this one? So here within the main program, we need to declare the new student and the student. So let's say, for example, again, student type. Then we have the student, comma, and then we have the new student, semicolon. Okay. And then, for example, I want to ask the user to provide for the name, last name, and then for the testing test score and the programming score. Course grade will not be the input, and the GPA. GPA is computation of the T-score and the P-score. So what should be the code within the executable statement? So we're going to prompt the user to enter first name. Then we have get line, since that's a string. We have cin, and then we're going to make use of, let's use new student. New student dot. Then automatically it will have the IntelliSense. So just choose, you may choose the values or the members of the structure, then press enter key, semicolon. Then see out, enter. last name. Then again, get line, cin, new student, dot last name, semicolon. Then, let's ask the user to input the test score, and t-score. Cout, enter test score. This time cin, and then new student dot t-score. Then another one, cout, enter programming score. Cin, new student dot t-score, semicolon. So we already asked the user to input the 4 values for the first name, last name, test score, programming score. So what are we going to do now is to compute for the GPA, and then we're going to do the equivalent value of the course grade, which is A, B, C, D, and F. So let's compute first for the GPA. So how are we going to compute for the GPA? Then again, new student dot GPA equals new, let's have the parentheses, new student dot t-score plus new student dot t-score divided by 2, semicolon. So that's how are we going to compute for the GPA. Then after getting the GPA, let's compute for the equivalent of the GPA. So let's go back to our example here. So if my new student dot GPA is greater than or equals to 90, we already can assign the new student that C grade to A.